This AP Calculus question is wanting us to find the equation for the line tangent, or the equation of the tangent line, to the graph of this equation here at this given point. Whenever we're going to find the equation of a tangent line, this is really the same as finding the equation of a line like you always did even in your algebra classes. And what we're going to be using is going to be point slope form. So the point slope form for the equation of a line looks like y minus y1 equals m times x minus x1. So why we call it point slope form is because we need a point off of the graph and we need the slope in order to use this. Well, to find the point is always an x and a y. That's really coming from your function value. You think about it as I'm going to plug in an x value to my original equation, and whatever the y value is that comes out of there, that's going to be my point. When it comes to finding the slope, well, the slope is kind of the new game in town. In calculus, we find slopes using our derivative. So f prime at whatever that x value is, I would just call it x naught, that's going to equal our slope. That's going to be our m. So let's go ahead and start putting our values into our equation and see what we get out. Let's go after the point first. Should be pretty straightforward. So to find the point, you're going to take the x value they give us. So they're telling us x equals -1. And we're going to plug it into the equation that they give us, which at first glance freaks you out, I'm sure. When you're like, I don't know how to plug an equation, an x into an integral and get out a number. It looks all sorts of nuts. Well, guess what? You're probably not going to actually even have to take the antiderivative here. And really what kind of tells me that is when I see that x sitting up top here, that really is sort of bells and whistles that this is going to be a bit more straightforward than you think. So the way we always find the y value is we take our x value and plug it in wherever we see x in the equation they give us. So again, don't overthink it. Just do what you would normally do with an x and plug it in. So I get -1 to 1 e to the negative t to the third dt. So what goes on now? Well, if you look, you have got matching bounds. The upper and the lower bound match. And anytime the upper and the lower bound match on an integral, you could really care less what's going on inside there because the answer to every integral problem like that is always 0. So what we would be looking at is y equals, we've still got this 3 plus 0, so y equals 3. So we just found our x1 and our y1 that we need to go ahead and put into our point slope form. Now let's go do the other part of the puzzle, which is we need to go find the slope. Like we said, the slope is going to come from the derivative. Normally we would call it f prime of x. Here they're talking about the equation in terms of just calling it y. So we're going to go find y prime. So we get y equals 3 plus, and then the antiderivative -1 to x of e to the negative t to the third dt. Well, to find the derivative, we would dx both sides of this equation. So we're going to take the derivative of both sides. On the left-hand side, the derivative of y is going to be dy dx, or y prime, like we've seen up here. And then as you work your way through it, the derivative of 3 would go away. The derivative of a constant is 0. And then again, when you see this x up here, this is what they refer to as the Fundamental Theorem of Calculus, Part 1. Remember that derivatives and antiderivatives, they cancel each other out. They're inverses of each other. It's like when I've got x squared and I square root it, the x squared and the square root cancel each other out, and I'm left with just x. So again, these are, little identifiers you got to pick up on. Is when we've got an x up top there, these things are just going to cancel each other out, and that x usually just drops straight into that equation. So our derivative on this is just going to equal e to the negative x to the third. And then we just need to find out what's happening at our specific x value. So if we do dy dx evaluated at x equals -1, that's what that little bar means right there, is evaluated at. So that's just saying take and plug -1 in for x into our derivative. And so we get e to the -1 to the third. -1 to the third would be -1 times another negative would give us a +1. So out of there we would get e to the first, which we could just call e. So this is our slope, this is our m. That's the other piece of the puzzle we needed to put together our point slope form. So now we'll just finish this up by following our point slope form equation. So we get y minus y1, which is the y value we got out there, equals m, which is what we just got out here. We get our slope from our derivative, times x minus x1, which is a negative 1. So we would get minus a minus 1, which would turn that into a plus 1. And so that is the equation of the tangent line. And you would just go look and find it, and we can see that our answer would be option C. So what you learn from this is you better know the point slope form for the equation of a line like the back of your hand. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.